All right, guys, welcome to another session. So this is going to be office hours, or more colloquially called doubt clearing session or Q&A session. More importantly, first, I'll just walk you through the assignment, and maybe hopefully you can keep asking me questions asynchronously. And also, idea is maybe if we have time, we'll keep one of you on hot seat. What hot seat is? Nothing. It's very simple. So one of you, I'll just randomly call, or you can volunteer, can share the screen and start walking through what they did, etc. And we can start sort of, if he or she has any questions, we can start solving them. Idea is obviously if there are, like, say 9 participants or 50 participants, all of them might not get a chance, right? So, but hot seat will give one person, just because one person is going through that grind, everybody can learn through those step by step steps, right? Because people make almost the same kind of mistakes, right? So there's nothing going to be new. Okay, so what is the first assignment about? So it's not yet auto graded. We need to spend some time on that. It's on the first module. So if those of you have not finished the first lecture, please go ahead and watch that lecture, right? There he did a lot of exploratory data analysis. Very, very simple, extremely important. And so the data set we used is nothing but the adult data set, right? So first thing, what is asked? Load the data set via the URL. I think that's super easy, right? Perhaps I already gave this. So let me run this. Loading the dataset via the URL. So it's in the .data format. Don't worry too much about it. The other different kinds of formats are okay. I had to get rid of this raise implemented error. So that's just one small condition I wrote. As I'm fixing. Suppose if it's let's say it was something else like HTTPS path to document. And let's say the document was called adult.csv. You just say CSV, okay? Same thing if it's an Excel. Right? Same thing if it's an Excel. You just pretty much use the same. And same thing if it's a, what are the other types? SQL, etc. Correspondingly, these things will change here, right? So you have to say, okay, I'm going to read my data and call it adult data set. Adult data set equals pd dot read underscore CSV. In this case, data underscore URL. That's pretty much it, right? And that's pretty much it. So this should solve the problem. Okay, sorry. Adult data set. Okay, that solved the problem, right? So we have a beautiful looking data set, and that's pretty much it. Now I've given you some assert conditions. You can just double check that. So here it's asserting that the column headers is 15, so on and so forth. Let's see if it runs well, right? Okay, we need to create a column headers. So column headers equals, what are the column headers for these guys? So, oh, it's right here. So I'm going to copy paste this, all these column headers. I'm going to put it here. So push this here. And this is here. So I'm just going to say columns. Okay. I forgot what is the hot command to do this. Let's check this now. I think, is it columns or column headers? I forgot. Columns. Read data set with column headers. Yeah, sometimes, the basics are also kind of icky. I think it's call underscore names, right? Not this. Yeah, let's go to the library and documentation. Okay, it's header. Let's try header. Okay, not header. Whoa, so much in read. Let's actually look at, I think this, I gave this in the, let's see. Oh, names is, oh, that's it. Yeah, that worked. Okay, perfect. So names equals columns. Sorry. Yeah. Sometimes, you sort of have to go and pick up the syntax. Okay, so I kept all my column names as columns, which I copy pasted from the definition that was above. And then I, placed them as names, right? So, okay, cool. And now I should run the assets. Okay, so this guy needs to change. Column headers, names equals column headers. Let's try this. Now let's try this. Okay. 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 Kind of annoying, but yeah, let's just be factually correct. Yeah, that's the beauty about the autograder. So once I have the autograder set up, almost all my assignment submissions can be autograded. Okay, so I successfully finished task one. Hooray! Awesome. Any questions until here? Everybody, guys, come on. Samiksha, Govardhan, Vishnu. Let's have clear. CLR means clear. Prem, Pujari. Okay, perfect. So now let's move ahead. So I'm going to say, what does this guy want? He wants the first. So I'm going to say adult dot head top 10 rows. Does that work? And same thing, adult dot tail equals adult dot tail, right? That should give me the tails. Okay. Yeah, I got the second one too. No hiccups. Third, count the number of int64 variable times assigned to the number. Okay, so I'm going to say, let me start counting from here. Let me start counting from here. Okay, so what does he need? Count the int64 type variables. Okay, so let's see this guy. Adult dot info should do it, right? Okay, 32,561 rows, 15 columns, looks very big. So what do you think, guys? What should I try? Let's look at the Skype. Okay. Let's look at D types. Okay, yeah, I think we can just manually count. Yeah. So let's say if I did info, he needs the number of integer 64. So by definition, age is 1, FNL weight, education number. So I had 3, 4, 5, 6, 7. So let's just say 7. And number of objects. So the rest are all objects, right? So I have 15 minus 7. That's 8. So hopefully that should work. So I haven't written the test here. We haven't set that up, but I think this should be the answer, right? Um, Data frame dimensions. That should be straightforward. So let me say adult. Yeah, you can also do value counts. No, but value counts, no, this is more basic, Ashok. So value counts will give you the number of elements inside that, right? We're just looking at basic, the column types. Yeah, let's see this adult dimension. Let me copy paste this guy here. Find the dimensions of a data set, okay? Dot shape should do it. Yeah, I got that right. Tuple and the row dimension should be listed for it. Yeah, so there are 32,561 and that's the first row, okay? Shape method. So I also gave you a hint there. Okay, good. So yep, I have created a tuple and yeah. How many missing variables? So let's look at that. Let me do missing variables. So I'm going to say adult dot is null dot sum. Remember that, guys? So these are all the missing variables. Count the number of missing variables. So he also wants that. So I'm going to say this adult missing equals this dot sum. That should be it, right? Yeah, voila, that ran. So the tests are not there here. But did everybody get 0 here? Any questions until this part, guys? Now is a good time to just have a checkpoint on the assignment. There are multiple ways you can do it, so it doesn't matter. The end answer is what matters, right? So let me see. She should. So that's 0. Yeah. Okay, good. So viewing data frame statistics. Let's look at the summary statistics of it. Yeah. Okay, describe. Find the mean of this guy. Okay, let's find the mean of this guy. So mean age equals adult. Is there a column called age? Let me just see that. Yeah, there's the guy called age. Find the mean of age. So I'll just say this dot mean. Mean age should give me the mean, right? Oops, spelling mistake. Yeah, 38.58. Now, I got the mean age. Did everybody get the mean age? I think this is easy, right? But any doubts here also, no problem. You can ask me. Next, find the standard deviations. Okay, let's look at the standard deviation, guys. So and he wants me to assign it to HPV. STD. Okay, let's do adult. And what is the name of this guy? Hours per week. I think, what is the command for STD? I forget. Is it STD? See, it seems like it is STD. I think it's STD EV or something. It doesn't have that. Okay, let's look at the documentation. Standard deviation pandas. Yeah, it should be STD. Why did that not run? Oh, I forgot to put the brackets. Okay, yeah, silly mistake. Yeah, so I got the standard deviation as this. Just for sake of looking neat and elegant, I'm just putting this in two different. I got the mean as 38.6, and I got the thanks, Samiksha. I got the standard deviation as 12.35. Okay, perfect. So hidden tests, I think they're pretty much the same. In fact, you can even write the test assert statement. So how do you, I mean, to make a Jupyter notebook autogradable, all you have to do is this. Yeah. So you do this assert statement. Okay, is instance, forget that. I think it's not instance, it's the value. Yeah. So let's say I do this, right? All you have to do is, I mean, this is not required for you, but just some extra cool tricks. So I say assert mean age equals 38.58. Hopefully you should work. Let's see. Okay, assert round. What is a rounded value of 38.58? Should be 39. Let's check this now. Interesting. Oh, oops. Mean age, and I get rid of the column. Yeah, see, that's it. So that's the test. My only actually honest challenge is that I have to pipe this and make it into Canvas. Canvas is the problem. The guy is asking me to pay too much, which is okay, but I have to figure that out. Okay, just ignore this. This is how you can make notebooks auto-gradable. There's also one more software called NB Grader, so I'm asking my team to work on that. Anyways, coming back to the main topic. Task 7, straightforward. Summary statistics for non-numerical columns. What is he asking? We have some columns in the dataset that are non-numeric or object columns. Fair. This is usually a string object. Let's use the describe function, but include the argument exclude equals number. Okay, let me do that. Yes, Your Highness, I'm going to do that. So I'm going to say adult dot describe excludes number. What does that give me? Oh, I think I've written the answer here. Okay. Now, these are the only columns that are not numerical. Okay. Find the number of unique education values assigned to unique. Okay, let me do this guy. So I'm going to say unique edu. Come here, grab here. And I'm going to say adult education. How, guys, how do I get a column inside this? Dot and that should do the trick. So how many is that? 16. Did you guys get 16? How many of you got 16? Please say yes on the chat. Guys, come on, others also. Back, Samiksha. Vamsi, others. Okay, perfect, guys. Yeah. So, okay, forget this. All right. So 16 is easy. Okay. So I think seems like my task 7 is done. Is there anything else? Or he's asked something else. Find the number of times the most frequent observation of income occurs and assign it to freq dot underscore income. Okay, let me do that. I don't know why I did this here, but let's just keep this guy here. Find the most frequent observation of income. So adult, I'm going to income dot value counts. Okay. So now I'll get the most. Yeah, that's why I did that. So it seems like the most frequent income is less than or equal to 50K. So the answer here is find the number of times. So the answer is 24,720, right? Okay. So the answer should be 24,720. Guys, you got this also, right? If you feel like I got something else and you got something else also, let me know. Everybody must do this before we move to the next one. Okay. So I think task 7 is done. I don't know if there's anything else in task 7. Finding value counts. Okay. Let me get rid of this guy. Let's look more specifically at the relationship column and perform a count on the number of observations for each category. We can see how many categories we have by using the dot unique method of the column. Then we can use the dot value counts to count the number of observations. Find the unique values in the relationship column with unique. Okay, adult is given so many hints, right? So is there a column called relationship? I'm assuming there should be. What should I assign it to? Nothing. Okay, these are the, seems like these are the view the number of six. That's fair, straightforward. Can we use more to see the most frequent observation? Yeah, you can. Yeah, we can use to see the most frequent observation. So, but which one are you referring to, Samiksha? Are you saying you want to do it with for this guy, the previous one, less than 15 equal? Yeah. So let's try her method. How would I do for mode? See, since only two of them are here, right? So let's look at the mode. The mode is coming to less than or equal to 50K. You get the mode, but he's asking the number of times the mode has occurred. No, how do you get that? Samiksha, your concept was correct. Mode will yield the number, the thing that's very, very frequent. But I want to know the frequency of that. So for instance, if you look at this column, another trick that you can use is just this. You look at describe, right? And then you can just get all the hints here. So you want to see mode and 0. Okay, let's try that. What does that yield? See, mode is mode is something that will give you a single element, right? So mode is giving you the most frequent. Mode will not have anything else inside that, right? Mode with value counts. Yeah, then that's fine. But kind of an overkill, no? That's also fine. So she's saying let's do. So if you're doing value counts, that itself is the first one. That means it's the first element, right? So you could say value counts and then just print out the first element. You wouldn't do mode. See, what is value counts doing? Value counts is a simple technique to actually show. So for one variable, how many such occurrences have there? For second variable, how many such occurrences? For third variable, how many such occurrences? So on and so forth, right? So let's say you went to the market, you bought some stuff, right? So number of bananas, let's say in the entire basket was the highest. You had 4 bananas. Number of apples, 3 apples. Number of oranges, 2. So value counts itself is giving me that. The value counts inherently is giving me 4, 3, 2, right? You don't have to use a mode on top of that. Make sense? You either use mode, but the limitation there is mode is telling me I bought the most number of bananas. Mode is not telling me how many bananas did I purchase, right? You bought 5 bananas, but mode is not telling me. Value counts is actually giving me the entire, like, it's called the basket analysis, right? Market basket analysis, very big topic. But it's saying orange, bananas 5, apples 4, oranges 3. That kind of a detailing it's giving me. Okay. So, okay, good, guys. So let's, I'm going to get rid of this, okay? Because if it's not set up, but presuming if I had submitted on Canvas those other extra code would have would have been like should have thrown errors. All right. So you have adult relationship dot unique and unique. So everybody's clear up to here. Any other also different methods? Feel free to like talk to me. Ideate with me. So you can flush out all the concepts, not just flush out, but you can go in depth, right? So that, like the way Samiksha was sort of correctly thinking, but you must also know what is the sort of a limitation of each syntax, each command, right? So they're powerful, but they're also they have like some shortcomings. Okay, so we don't have a hidden test here. Create a series. Series is very simple. You know what series is, right? It's so I'm going to say adult. Did I spell adult correctly? Yeah, I spelled it correctly. So he wants to call it, she wants to call it adult occupation, adult, and this should do it, right? Hopefully there's something called occupation. Yeah, that worked like a charm. Perfect. So have you created the correct series? Yeah, even my assert statement is correct. Practice with a new data set. Okay, let me practice. Right. Okay. I'm just going to do data. Come on. Come. And I'm going to, yeah, that's there. And I'm going to call this guy NASCAR. So you guys follow NASCAR, right? NASCAR is the equivalent of Formula One races. So like just like Americans, you know, I won't say copy, but try to do things exactly exactly different to what Europeans do. So F1 race, Formula One race is European. NASCAR is the American version. But like American football versus soccer, so on and so forth. NASCAR equals pd.read underscore CSV. And I'm going to say, I'm going to drop this guy. Data URL on 2. Okay. And what does he want? He wants me to read it or he wants me to write it. Okay, he wants me to read it. So let me just double check if I've read it correctly. No such directory. Whoops. Oh, I made a rookie mistake. I put those in quotes. Okay, cool. Don't make rookie mistakes like me. Okay, assert statement. Yes, I've created. Now let's look at the header. I did look at the header. Oh, it seems like the column headers are also neatly done. Okay, so I don't have to do anything there anymore. Sir race, year race, finish, start, laps, price, cars race, cars make, driver. Okay, everything is very, very nicely given. How many of you follow F1 Formula One? Anybody? Or you guys very, very determined only to be data scientists? Do nothing else. Okay, so I'm going to say NASCAR head equals NASCAR dot head. Okay, remember the head should have only 5 items. I've done that on top, but this should work. So let me just do it again. NASCAR dot head. Write that again. Okay, looks good. Looks good. Dataset description and variable types. Using your NASCAR data frame, answer the following questions. Remember, you can use describe info to print out the information. Okay. You can move on information. So let's just keep this link handy. Select the letter indicating which one of the following statements about the features in NASCAR is incorrect. For incorrect, he doesn't want correct, he wants incorrect. Remember, for example, if statement B is incorrect, you will type your answer in the code block as answer equals B. Okie dokie. Let me do that. So I'm going to say answer equals each entry for driver is a text string. Car make is an identifier variable. Car race is quantitative discrete. Price is a quantitative continuous variable. Each entry for driver is a text string. Let's look at that. So A is correct. So it cannot, okay. Yeah. Let me get rid of these. So A is correct. So it has to be between B, C, D. Car make is an identifier variable. Let's look at that. String of length 9. Let me double check that. So identifier variables are ones that you can use to uniquely identify, right? So like the Aadhaar card, right? But can I uniquely identify the car based on that? Let me just actually check this guy. How do I check it? I'll hit a describe and check. Okay. Let me just include everybody. Car make. Yeah, so there are 10, only 10 unique. Rest are all repeating. So I don't think car make is unique. Car make is an identifier variable. Okay, it could be B. So let me just put that. It could be B. Let me understand that better. So let's get rid of C and D. So let's look at C. Cars race is a quantitative discrete variable. Cars race. Where is that? Number of cars in a race. Format F2.0. Is quantitative and discrete. Yeah, so cars race is definitely discrete, right? The minimum value is 22 and its maximum value is 50. It's incrementing in integer values. Definitely not. So C is correct. So I can get rid of option C. So it's between B and D. So let's look at D. Price is a quantitative continuous variable. Let's look at price. Price. Where's price? Series raise. Winnings. Seems like winnings. Sorry, beg your pardon. Winnings format F7.0. So let's look at that. Price 12035, 1881315, 6535, 3835. Price doesn't seem continuous. So minimum was 0. And max was some 2.3 into 10 power 6. So that's like 2.3 million, right? Price is also discrete. So definitely D is the answer, according to me. How many of you guys got D as the answer? Yeah. Others, guys? Yeah. So I think according to me, D is the answer. Uh, uh, Actually, wait, hold on. I think both B and D are incorrect. I think both B and D are incorrect. See, the reason why B is also incorrect is that car make is an identifier variable. Car make is not an identifier variable because there are only 10 categories. There's Chevrolet, there's so many other things, right? So, like I said, identifier variables are ones like Aadhaar card, etc., or to some extent like phone numbers, where you can uniquely get the person back. So I would do both B and D at this time. So for those who got D, you're partially correct. Those of you got B, you're partially correct. Others, if you got B and D correct, that's completely correct. Others, unfortunately, that might not be the correct answer. Any questions on this part? Cool. So then we have extra practice. So extra practice, I think you guys have we've done this, right? You know how to upload a file from, right? How to. So let's say I want to upload a file on my notebook. I simply say this, then I say this, I run it. You've seen this. So let's say I want to run some PDF. So this is some paper that I want to push, and voila. Yeah. So see, categorical variables are just variables, that have categories. Identifier variable is a type of a category variable that you can use to uniquely identify, such as phone number, or assuming a phone number corresponds to only one individual. Aadhaar card, definitely. So it's a variable, right? It's a category, and it's uniquely able to identify that. That's it. But a car, you can't. Like, there can be so many types of Benzes. But if I say Benz, Mercedes, but with a unique number plate number TS09EL 5469, the number plate will be a unique identifier variable. Okay, but just Mercedes or just Tata Nano, that's not a identifier variable. All right, cool. So I'm gonna. Any other questions, guys? Vamsi, I thought you had a question, or that was resolved. Any other questions? If no, then we can go on to the lecture, guys. If you're clear, we can go on to the next lecture. Just type LEC lecture, and then we can go to the next lecture. Perfect, guys. So let's go to the next module. So it's a simple explanatory visualization that we'll be kind of covering. So by now, by the end of this lecture, you should be able to understand, how do you draw very useful diagrams. See, diagrams are very important because as much as data science is a lot about programming, coding, mathematics, statistics, looking at insights, it's also about visualization. Why? Because like people, people say, picture speaks 1,000 words, right? So let's look at some basics of how to, create graphs and charts. There's an entire curriculum on this. You can go very deep into this as well. So you can do Microsoft Power BI, Tableau, etc. Perhaps if we have time much later, we can do it. That's strictly not included in this syllabus. It's also not required because unless you want to take the path of a Power BI certified user, etc. There's nothing bad in doing that, but I would dissuade you from doing following that path, because you guys are smart. Do the data science, AI, Pythonic way. Making charts, visualizations is great. That gets you almost on borderline consulting. Problem with that is it's not that lucrative, right? It's not that. That means also you have to improve your soft skills, etc. I've seen that people who are very core techies are not great in soft skills, and who are very good in soft skills are not very great in tech. Somewhere in between is the data analyst or BI analyst. It's also called business intelligence. So you have to make the choice depending on your familiarity with yourself. So everybody overestimates their strengths and underestimates their weaknesses. Sorry, yeah. So that's exactly right, right? But you have to be very honest with yourself what you want, right? It's okay if you can't do AI and all, it's fine. IQ, like everything, is normally distributed, right? But EQ is not. So be very clear what you want. We're going to be teaching basic and good visualizations so that you're able to at least present few graphs, etc. And by all means, this is very, very enough. Nobody in some serious company is going to ask you like make thousands of graphs, etc. Right? If they ask, then you have to relook at that job. This is more than enough. In my 7-8 years, or probably since 2012, or it's going to be 10 years, I've not used more than these charts, right? But have a complete grip on this, right? Okay, so we're going to look at bar, pie, some heat maps, scatter plots, histograms, box plots, right? And some heat maps. Some cool plots are there, Sankey diagrams and violin plots. We're not going to be looking at that, but I've given you links. If you want, you can go through that. The evergreen and extremely, extremely ubiquitous, everywhere you've seen the Titanic dataset. We'll also be seeing that. I've sourced it from directly from Stanford's lectures, etc. This one. So here's the credit for them. It's important because you have like data set is good and you have some good healthy understanding of this as well. So what I'm going to go straight, I'm going to load this, and remember my two visual packages I need, matplotlib and Seaborn, right? So I get these guys. Data set looks nice, beautiful. I'm going to look at the frequency of sex. So how many men and women are there? So apparently there were 573 men. The rest were females. So I'm going to do just value counts, right? So, and normalize equals true. What does normalize equals true mean? Just on a scale of 100. So what is that? It's actually giving me what? It's giving me 573 divided by the total. What's the total of 573 plus 314? That's 887. It's giving me a percentage, right? So I'll actually write the numbers. That's better. 573 plus 314. So it's giving me that, right? So each that's the numerator, that's the top, and female is the just the other number. So let me write that 314 divided by 573 plus 314. Okay, guys. No rocket science here. Very, very simple. Value counts is giving me that, and if I want to know in a scale of 100, it's giving me those numbers. Now let's just, for fun, plot a bar plot. What are bar plots? Simple. A plot with bars, right? And these are the default colors, so you don't even have to tweak it. So it's a category plots. Okay, cat plot is category plots. Nothing too exciting here. So what is the syntax? I do cat plot. First, I give the data set source. Data equals data set, right? Comma x. What is x? On my x-axis, I'm going to give you the column name. That's the syntax, right? And what is kind? Kind could be count. It could be other things also. Remember, how do I check more about cat plots and etc. the library? One way to do it is go here, and I told you, right, Seaborn documentation, right? How did I do that? I just went and checked on the internet. And remember, on the internet, always go to the original library, right? So it's going to take, Seaborn has a lot of these interesting things. And these are all the what? Are these arguments or parameters? These are the arguments it can take inside. Whatever it absorbs, like the food you eat is called the arguments inside, and whatever you excrete or whatever is called the parameters in this case, right? So remember this, whenever you're trying to like, oh, he's changed it, sorry, parameters and arguments or returns, parameters, whatever I said, just flip that. So parameters is whatever you take as input, okay? So what can it take in terms of kind? So let's look at what this argument kind can take. So let's say kind. The kind of plot to draw corresponds to the name of a categorical access level plotting. Option, strip, swarm, box, violin. Don't do all those things. You see, remember, it's not about how much you know, it's about what you should not know, right? And I'm telling you, cut all of that, right? Just point shooter style. What is industry asking? Count. So just remember count. If you have excess time, if you have lots of other things, then you go pick it up. But right now, like remember, like I said, for the next whatever 60, 90 days, just learn what it takes to get go through the hoops, nothing else, right? If you have to run a 100-meter race, just run 100. You don't have to run a 200-meter race, right? So just learn count. Now going back here, so I did count, and I let you play around and do the other ones. Now plot.x label, extremely simple. So it sets the x label axis as passenger sex. Yeah, incredibly easy. Plot.y label of frequency. Okay, that sets the y label as frequency. So here I would like to deviate from with respect to others a little bit. In that, I also want you to make the ability to make quick graphs on Excel sheets. How many of you guys are proficient in Excel sheets and sheets? If you're proficient on Excel, just say, I am. If you're not, it's okay. We can go through this. Just say Excel. If you want me to go through this on Excel also, just say Excel. Perfect. See, it's very, very important you have a hands-on knowledge of Excel. The guy who made Excel is a multi-billionaire. He's been the world's richest guy since the last 20, 30 years. So he's not a fool. He knows what he's doing. Or if I were to tell you that all the operations of data science can be done on Excel, minus even neural networks actually, does that blow your mind? It should blow your mind. Excel is incredibly powerful. And there's a reason it's powerful. If almost 1 billion people are using that, then there's actually some merit in that, right? Extremely important in industry. Don't always go, oh my God, let me do a data science way to just figure out a simple bar chart to plot men and women. Don't do that. So the way I would do it is, so always you should have a working knowledge of Excel. So I say Titanic, so serial number 1, 2, I'm going to do the same thing here. So what was the gender, right? Sorry, count. I'm going to say gender, right? Gender male, female. So here in male, I think he had what, 570 something, right? 573. So let's put this guy here, 573 and 314. Okay, 314. That's it. So, and what is the exact column names? Sex, male, female. So I'm going to change this. Yeah, okay. So this is the exact. So how do I insert a bar chart? Very simple, very fast. You must be able to do it. So here I'm going to show you. All I do is I'm going to hold it here. I'm going to press shift. I'm going to go front and back. So I get this grid. That's it. And all I do is sorry. I don't know why that came. All I'm going to do is insert chart. As you saw what I did, I just went insert and I did a chart. Voila. Google Sheets or Excel. So I'm using Excel because I'm on a Google Sheets because I'm on a Mac, but the syntax is pretty much similar if you're using a Windows. All I simply do is, so this is a neat pie chart. We're not going to be using a pie chart for this demo. We're just going to be using a bar chart. Voila. I got male, female. Does it look similar here? It looks incredibly identical here. So I'm going to set the first thing and data range. What did it take? It took B23 to C24. What is B23? Let me actually go and see the B23. I'm going to get my B23. Voila, B23 till C24, right? C24. Can you see that? So it nicely gave me a graph, nice bar plot, and it came out very nicely. And then the rest of the sort of I'll tell you the main things to be done. Okay. Data range, it got nicely. Male, female, it picked up. You can keep adding a lot of things. Let me customize other stuff. Chart and axis titles. What is my chart title? Count versus sex. No. Titanic. Okay, let's just say count versus sex. Okay. And I can do some nice colors here. Some green color. That doesn't look good. Just blue color. And I can just center it, justify it, and all that. Okay. So the graphs look nice. So you can quickly in 10 minutes make some graphs. In fact, you guys should do that. You guys, let's say if you want to stand out and actually get a job literally in 2 weeks, I would just go to Covin app. No, I'm not joking. Go to the Covin app, download the details of your state. You know, what is a vaccination and not vaccinated. Make some nice 5 plots like this. You know, number of people above 18 plus, 45 plus, etc. And just publish it on your Medium and LinkedIn, and bam, people will be coming to you, right? So simple, unique things like this is really going to be attractive. Series, left axis, right axis is pretty self-explanatory. Just play around with this. There's nothing more in this. So, you know, you can create very powerful graphs just by actually going through these elements and actually doing a lot of stuff. So we'll get to the rest of the syllabus and then we'll come back. So remember, keep a workbook. Always be able to do whatever you do on code on your Excel. That means you remember it. If you cannot do something on Excel, even if it's the most complex algorithm, then you haven't learned it. You're just, I'm sorry to say, like rotating it or mugging it up, which is not a great way. It's good in the short term, but it's not long term, right? Okay, let's go back here. So plot number of male and female passengers, so on and so forth. Oh, data set is not defined. Oh yeah, this which is writing syntax. So get rid of this guy. Okay, Seaborn. Now we're going to do the pie chart. Extremely important in most business worlds, right? So I know you're a data scientist, but consultants love it. Now, when I was doing consulting, I used to work for KPMG very briefly. People used to use charts, pie chart, especially all over the, like literally, if you didn't do 10 pie charts, you wouldn't get your salary at the end of the month. I have no idea why. But I found data, and it's actually good. It's exploited in consulting industry, but it's underutilized in the data science industry. You must use a lot of pie charts because there's something about a circle that people can remember. And when you show them 3 or 4 slices, I don't know if people remember a pizza or whatever, but people remember pie charts, right? Even somebody who's like from elementary school will understand a pie chart. Bar line starts becoming complex, but pie, I don't know, people love it, right? So you must be proficient in pie chart. So let's actually do a pie chart now. So let's look at the syntax. So survived proportion. So I'm going to construct a pie chart of who survived and who did not survive, right? So apparently 39% only survived. Yeah, that goes with history, right? About 70%, sorry, 60% dead. So now how am I going to get those numbers? So I say survived population is equal to, proportion. So I look at the Titanic survived column, value counts, and I normalize as true. And I'm just going to rename this index. Did not survive as 0 and survived as 1. So I get these very nice numbers, 61% and 39%. So here is a syntax to create a pie chart. So number 1, I create figure comma axis equals plt.subplots. Now what does this do? This creates an instance of a subplot. Subplots are just plots, and you can specify 2 by 2 or 3 by 3, so on and so forth. So just instantiate that in the beginning right away, right? Now look at the syntax. It's an icky syntax, but keep it, remember it. Don't have to do too much around it. This is like ramen noodles, right? Just remember where to get the ramen noodles and then start tweaking them. That's it, nothing else. So I'm going to do axis ax.py survived percentage, and I'm going to fetch that from the survived column. My labels survived percentage.index, right? And my auto percentile 1.1 f. So that is actually trying to write the float inside the pie chart. And my start angle is 90 degrees. Okay, just remember the syntax. Don't do anything extraordinary with it. Next time to create a pie chart, just use this. And I run it. Set axis title is here, Titanic passenger, so on and so forth. So did not survive and survive. That's it. Voila. Nothing extraordinary here, because this is where you cram a little. Just cram the syntax. Don't do too much about it. You don't have to learn too many things inside the nitty-gritty of what's this called, visualizations. Let's try to do the same guy in my workbook. So I'm going to insert a chart. Nope. The graph I'm going to do is okay. That's weird. Why did it take? Let's actually get a bar chart. Sorry, pie chart. The first time we got a pie chart, why is it not allowing me to do it now? Let's see this. Okay. That is weird. For this, it suggested. Okay, why is it not suggesting for this? Okay, finally, there you go. So here is the Excel way of doing it. Very, very simple. And I've been able to do the same in literally 2 steps, right? So this is your spreadsheet way. Now let's look at what are the other things the spreadsheet can do. So labels is straightforward. How you can get labels. Values is also straightforward. You can switch rows and columns. That's just a transpose. No need to use that here. And let's customize this a little. So I can change the chart border. That's not that useful, but in case you want to like just beautify it a little. Font, you can change the fonts to whatever you want, right? Pie chart. Let's look at what this. Oh, you can actually make a donut here too. That looks much better. It's automatically showing you the percentage, right? Inside it. The same thing we got it here for the in our Jupyter notebook as well. So label font size. I'm not going to do too much there. Did not have a percentage. You can adjust the colors. Same thing. Chart axis, chart title text. Titanic survived, right? Let's just do that. There you go. And I'll just center it for beauty. And legend, right? So the position is auto. Leave that. That's pretty much it in terms of doing it on your Excel sheets and doing it here, right? So this is the syntax for the pie chart. Now, let's deal with some quantitative variables, right? So let's look at some fundamental definitions. What are univariate variables? Variables that have precisely one, right? That's like that, and you can use pie charts or histograms to depict them. Multivariate variables, there are multiple variables. Typically use a scatter plot to show them. We'll see that as well. Now, like I said, so single quantitative variable, you use histograms, box plots, right? And now let's look at let's look at this a little more closely, right? So let's go back to our basics. So whenever you're trying to see the shape of distribution of a quantitative variable, It's always described by three features, right? Number of modes, symmetry or skew, right skew, left skew, so on and so forth, and outliers. We're going to look at each one of them very closely. And this is almost like the hallmark of data science. How, if you can recognize outliers and correspondingly know how to treat outliers, modes is important a little bit, and symmetry, if the distribution is right or left, so on and so forth, that's very important. Okay. This is also very important. Now, if you have one mode, it's called unimodal, right? So obviously, like, previously we alluded to, the mode is the most frequent occurring number in that data set, right? Now, if you have one mode, it's called unimodal. If you have two modes, it's called bimodal. If you have more than two modes, it's called multimodal, right? And if you have no modes, it's a uniform distribution, like pretty much just one number, very rare, right? Like, for instance, number of planets in the solar system across time is just one, right? Like Earth, forever. I don't think there's any other planet in the solar system. I'm not talking about conspiracy theories, but just saying the number of suns in a solar system, so on and so forth. Now, let's look at some sort of classical distributions, right? And what is right, left, so on and so forth. Skewness. Okay. If a distribution is symmetric, it's called, a distribution is called symmetrical if you place a mirror exactly in between, right? And it looks same on the left and right for its bar plot. So what do? Let's take a data set and I create a bar plot of it. And if the distribution in the midpoint area, like, or the mirror is left and right the same, it's called a symmetric distribution. Are most data sets like that? No. In real life, you'll never get it like that, but we would like to have that, right? Now, if it's skewed to the right, it is skewed to the right if the right side is very light, like the number of elements is very light, right? So what does that mean? Any examples that come to mind? What kind of distribution has that? It's light. Light means not that heavy, and heavy to the left. So you call it skew right if it's a lightweight on the right. So for instance, Indian population. So if you look at Indian population right now, most of the people, let's say 0, 1, 2, 3, 4, all correspond to like ages. I'm just making it up, like 0 age, 10 years, 20 years, 30 years, 40 years, 50 years. Lots of people, youngsters are there, right? We all know that. As people grow older, there are fewer geriatric population, right? So this Indian population distribution is skewed to the right. Now, any examples that come to mind for skewed to the left correspondingly, where it's lightweight to the left and heavy on the right? Perfect. Very good. Japan population. That's an excellent answer. Yeah, really. So if you see, Japanese are all like old. Apparently, so I saw this in not Game Changers. Netflix has this beautiful documentary about Richard Attenborough's planet. So he says, I think Japan, the population is decreasing, right? Because the number of births, the mortality rate is greater than the birth rate. So yeah, Japanese population. And another one is the current corona vaccination in India, right? I think more older people are all obviously getting vaccinated. I don't know about where you guys are, but definitely in Telangana here in Hyderabad, it's all left skewed. I didn't get vaccinated. I don't know about you guys. I hope you get vaccinated. But there's no vaccination for 18 to 45. There's definitely a lot of vaccination for 45 to plus, right? So a left skewed data. Everybody clear about that? Left skew, right skew? Just say CLR, means clear. Perfect. Okay. Let's look at an example, and maybe some of these are going to be now obviously extremely synthetic examples, right? I've made up. Non-symmetric bimodal, and symmetric bimodal, right? Symmetric bimodal is very idealistic. I haven't seen that. Uniform also, I've told you one example. Non-symmetric bimodal. Can you tell me examples of, again, data sets where there are peaks, but in some areas only? Anybody, guys? Player form. Okay. Oh, you mean like a cricket player's form? Can you elaborate on that? Okay, so you're saying if the player is a youngster or very, very old, his form is peaking. Is that correct? I think it's inverse form. Wait, no. Player form should, okay, I don't know, but logic says that player should, okay, wait, let's try to understand what you're trying to say. You're saying that if a player is very, very young or very, very old, his performance peaks, but in between years, his performance is less. That's not entirely true. Okay, maybe. Fair enough. Okay. I mean, I don't know enough. I have to look at some data set. Temperature, Prem. Temperature of what? Temperature of what? Like the atmosphere? So, so what does that mean? So 0, 1, 2, 3, okay, seasons. First, okay, there are no 9 seasons, but okay, the first few seasons and the last seasons have a lot of temperature, and the bit in between season that has no temperature. Kind of opposite, right? Summer has. Okay, yeah, I think I can give it to you. Maybe humidity with seasons. So, what are the 4 seasons? There's summer, winter, rainy season. Okay, let's say 3 major seasons. Okay, fine. How about non-gadget time? I'm just making it up. Non-gadget time versus age. Like time not spent on technology. I feel like infants 0, 1, 2, 3, I'm just saying that age group, and after 60, 70, they don't spend too much time on the technology, but all of the rest of them spend a lot of time on technology. When I say technology, like Facebook, social media, smartphones. Does that make sense? Yeah, basically, anyway, you guys get the point, right? Maybe my example, because I just sort of made it up right now, isn't very opportune, but isn't very analogous. But no, I said non-technology time. That's why I said, Ashok, it's non-technology time, right? Time outside of technology. So it's speaking. Hey, that's a good one, man. Samiksha has got a very good one. Peak restaurant hours, yeah. Let's assume 0, 1, 2, 3, 4 is like breakfast to lunch, and speaking there. Little lull in the afternoon, 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock, 6 o'clock. Again, during dinner time, it speaks. Yeah, that's a very good example, actually. I like that example. Yeah, that seems like a very good non-symmetric bimodal. And definitely, depending on the restaurant's reputation, maybe the mornings are a lot more rush. Or sometimes some restaurants are very good during only dinner, right? So Michelin star restaurants are restaurants that have that star rating. Okay, I think we've spent enough time. Anyway, skews are important. Model representations are important. I think we have spent considerable amount of time going through the basics. So in a way that you can recreate this. So tomorrow you get any question in any interview or any master's assignment or PhD assignment, you should be able to do it, right? So go back to basics, draw the 6 kinds of graphs. What are the 6? 2 of them you know straight away, right? Left skewed, right skewed. Enough examples are there for that. Symmetric, there are only 2. Symmetric unimodal and symmetric bimodal. Symmetric unimodal is an example of actually it's a precursor to the normal distribution. Then you have a uniform, and then you have non-symmetric bimodal, right? Perfect. So let's look at now the most important topic, arguably for tonight, outliers, right? So outliers are observations that appear very far from observations in distribution. So let's actually look at this. So let's say I'm just plotting salaries. So I'm just going to make these. Salary is, and these are all going to be units of in US dollars. Let's say. So I say 40K. I say 80K, and I have a bunch of other guys in 100K range, right? So these are three salaries. So these are typical salaries or remuneration, however you want to call it. Right now, just for fun. So what is the average of this? So I'm going to say, how to calculate the average on Excel sheets, right? So these are the average is 73K, right? So standard salaries in the United States. Now there's a new member who comes in, and that's salary X, and his name is Bill Gates. So obviously the salary here is going to be something very, very high, right? So let's look at how the mean changes. Old mean, new mean. So new mean is going to be so the new mean's changed, right? It's so I just wrote some very large number here. I think hopefully that's 10 power 9, $1 billion. And the means changed, right? The means shifted to that billion, right? So this number that's come here is not really, I mean, it's there in the data set, but it's not accurately representing salaries 1, 2, 3, and X, right? So that is called an outlier, right? Something that's completely different from a data set. It's very easy to pick outliers, right? Very, very easy to check outliers. Now, if you look at the current weather, right? Can somebody tell me outlier patterns? If I say it's going to say rain, 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 sunny, 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 what's current outlier going on in, let's say, West Bengal or Gujarat in the last several days? So let me write a data set here. Clear, rain, 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 cloudy, clear sky, typhoon, clear sky, cloudy, which is an outlier here. Okay, this might be better. Guys, which one's an outlier here? If I have a data set like this, come on, can you type it out in the chat, whatever you feel like? Perfect. Yeah. So tsunami is the outlier, pretty much it. So how did you find that out? I mean, through your gut. Your gut said that it's tsunami. Yes, it is. So weather abnormalities are typically outliers, extremely difficult to model, and there are at least millions and thousands of parameters, very, very difficult to model. That's why weather prediction is actually very, very tough. So meteorologists actually are doing a great job. So these are outliers. Now, it could be an outlier because it's really a genuine outlier, or it could be like so I maybe made a spelling mistake here, right? So let's say if I wrote, instead of clear, I wrote clear, right? So this could also be an outlier, but just because that's a spelling mistake or a typo, right? So you have to check the veracity. What is veracity? The honesty of that data point. Is it because there was actually something disastrous or something real that we should expect, or is a typo, or you couldn't find out? So many of these survey polls are actually null values simply because you just don't know, right? So be very careful. So here are the three types: typo, throwout, correct information, expect outliers, right? So let's look at a small data set. It's called body temperature data set, and you can do some interesting activities on it. So I'm going to read this data set, and let's look at the shape. So nice shape. It has person and temperature. Very, very simple data set. Nothing extraordinary. Let's look at the distribution of this data set now. I'm going to say plt.subplots. I'm going to draw the distribution. Let's look at the distribution. Voila. Seems like it is symmetric, right? Around a number called 98.3 or something, right? Can you see that? So in this graph, you can actually see that it's kind of symmetric around this line. 98.3. So that's actually the human body temperature. It's a no-brainer, and it's if you observe closely, it's actually getting this very beautiful shape. This is what you call a normal distribution, right? Whenever the shape is like this, it's always called a normal distribution. Yeah, it comes from the etymology is normal, and it has, even though it looks very beautiful, it has an ugly looking equation. We'll look at that equation. Some of you probably already looked at it. Now, so there's also a nice kernel density estimation. You don't have to worry too much about what KD is. What we have to know is how what the KD equals true does. So I say SNS dot distribution plot body temperature, and KD equals true gives me that small smooth curve, right? So here it's come a very, very nice curve, and if I just toggle it as false, I don't get that curve, right? So healthy human body temperature is 98.6, and we saw that the distribution is unimodal and symmetrical. So that's the famous normal distribution, right? So everybody clear about what is normal distribution now, or at least getting a sense of it? It's symmetrical, it's unimodal, right? Perfect. All right, now next, what happens if I change my bin size, right? So here, if you were paying attention, I kept 18 bins. So what are bins? Bins are I'm actually dividing these temperature intervals. So let's look at this again. I'm actually dividing each one of my temperature intervals. So 97, 97.5, 97.5, 98, 98, 98.5, 99 to 99.5. And in those intervals, I'm counting and I'm placing those numbers. Okay, what actually went on? Let me just look at it once again. So let me go back to my workbook. Remember, whenever I'm, trying to understand something, it's best to sort of body temp dot describe. Yes. Okay, one sec. Let me get this guy. Okay, so this is my data set. This is the original data set. Looks beautiful. How many elements are there? Let me just check. There are actually 223 elements. So 223 elements. So ignore that. So now forget the ID. That's not really that important. So what have I done with bins? So the first number is my minimum is 96.7. Can everybody see that? My max, let me just go all the way down. My max is 99.6. So this temperature, so what is the delta? Delta is just the difference. So I say 99.6 minus 96.7. That's 2.9. So these 2.9 degrees, I have created 18 bins. So if I say bins is equal to 18, so my first point becomes, my first point is 96.7. My second point is equal to 96.7 plus, so I have to divide 2.9 divided by this guy, the interval divided by 18. Yeah, I think that's pretty much it. So it should be 96.9. So my second point becomes 96.9. So I'll just say, yeah, I think it's correct. So it went till 0.18. So now the second interval becomes this. E7. That should be it. Okay, one sec. Forget about these pins. Yeah. So we have 18 bins, right? So I want to actually make all of those intervals and count within those intervals how many of these records are coming. I'm going to show you 2 or 3 records. The rest, you can just extrapolate from that. So my first point is 96.7. So how many records are there in 96.7? Precisely 1. So let's go back and check my plot. So in 96.7, guys, can you see that? There's precisely 1 point, right? How many of you can see this? Here, can you see that? Less than 96.7, there was nothing. Guys, if you're clear about that, just say CLR. You follow till me there, and yes, you can say CLR. Very good. So I've been able to get the first bin. Now my second bin is also very easy. So what is the second bin formula? Second bin is equal to, I started the first bin plus the interval, the delta. So actually I write delta. So it picked up delta. Oh, sorry. It's actually delta divided by the bin size. So that's 96.86. So my second point is 96.86. Let me go back there. So it is here. 96.86 is this data point. Right? Now I check how many records are there in and from till that 96.86. So 96.9 is also coming there. So I have first element plus 2 elements. How many elements did I have there? So I'm counting this guy, ID number 36 and ID number 254. So I have 2 elements here. I have 1 element in point 1. So on and so forth. So on and so forth. So I'll keep counting how many elements are there in each one of those intervals, and I'll construct my graph. That makes this normal distribution. Did you get the number of bins and this concept? If I decrease the number of bins, If I decrease the number of bins, I'll get a slightly different graph. Can I increase the number of bins? I can also increase the number of bins from like 18 to whatever, 24, 30, so on and so forth. If I actually keep increasing it, it's much better because I'll keep getting a more granular graph, right? So here I've increased it to 20. Let's look at the graph at 20. Kind of a little icky graph, but it is what it is, right? So now you can neatly specify the number of bins, check how many data points are falling in each one of those buckets, and actually plot them, right? So now let us look at the distribution of the age of passengers on the Titanic. Okay, so let's look at that. So I'm going to look at age. Remember what all features we looked at? We looked at last time gender. Now we're going to look at age. Okay, let's look at age. So I'm going to say the same. I'm going to declare my get my subplots. I'm going to say passenger age in years, frequency, and age of Titanic passengers. So just quickly, is it a right or a left skewed distribution? So when on Titanic, was it a right or a left skewed distribution? Very good. Yeah. So if it's lighter, whichever side feels lighter, not heavy, whichever side feels lighter and relaxed, that's the side you have to talk about the skew. So it's right skewed because indeed it is lighter on the right. Right? So here it is lighter, and hence that's why it's a right skew distribution. Perfect. Good. So now you know skews very well. Now let me look at a few more. So seems like Titanic was like India, extremely like right skewed. So let's look at a different data set. It's called sleep. Very, very easy. I have different animals, their body, their brain. SW sleep is a type of a sleep. Parasleep is another type of sleep. I think it's how long you've been hallucinating and all that. Total sleep is actually total sleep. Life, GST, PRED, exposure, danger. You also have the data dictionary here. Okay, sleep in mammals, ecological and constitutional correlates. Feel free to go there and check it out. Okay, because your assignment is also based on this. But it's simple. I just want to check mammals. Like I want to see how long a baboon sleeps, elephant is sleeping, so on and so forth. So let's look at these plots. Okay, total sleep, total hours of sleep, frequency, daily sleep in mammal. Okay, so just straight off the bat, animals sleep for which is the maximum amount of time? Total hours of sleep. What is the maximum amount of time typically? Guys, quickly from the graph. 8 to 9 hours. Very good. Yay, we feel good. we are just like the rest of the animals on the earth. I feel really proud and accomplished that we sleep 8 9 hours. Good. Anyway, but very interestingly, there are some animals actually that sleep 2.5 hours to 5 hours only, and we're not talking about Elon Musk. We're actually talking about real people. And there are some animals that sleep for 20 hours. I'm guessing it's polar bear. I don't know. Okay, so now let's look at something else. Oh, rats. Yeah. So actually, I think these smaller animals sleep for much lesser time, right? Oh no, total sleep is 8.3. Asian elephant sleeps only for 4 hours. Okay, I'm not a zoologist, so don't take my words for that. I'm a data scientist. But feel free to look at that and look at each point. So the distribution of sleep is multimodal. You can see many peaks in many areas, right? Mammals sleep different amounts of time depending if they are prey or predators, so on and so forth. So let's look at something very, very important. Let's look at box plots, right? We looked at yesterday, how we go about looking at the describe function and looking at the 25th percentile number, the 50th percentile number, and the 75th percentile number, so on and so forth, right? So let's go back to our workbook. So do we have that? Yeah, we have our sheet 1. Sheet 2. So let's say we have yes, just some numbers 1, 2, 3, 4, 5. I just change these numbers so that they look. So we have now 7 numbers. Straight off the bat, the median is, guys, how much is the median? How much is the median? Oh, interesting. Okay, median is 3. Why is the median 3? Because if I take these numbers here and I paste them here and I sort them. Oh, damn, sorry. I'm just going to make a new notebook. Okay, let me just sort these. Yeah, and you can see that indeed 3 is the median. That's the middle recurring number. If you sort it here, you'll pretty much know it. Guys, I did a sort here. Sort A to Z, and then it's showing that 3 is indeed the median. Okay. Now, what is the, so we've sorted these. Now we know the median. So I'm going to get rid of this guy. So I'm going to color my median. Okay, 3 numbers on top, 3 number. Yeah, that. No. Yeah. Okay. So this is median is also called the 50 percentile number. And which is the 25th percentile number here? Guys, which is the 25th percentile number? Excellent. So 25th percentile, how do I get it? Remember, when I'm watching a movie, what did I tell you? So let's take a large movie, like some Peter Jackson movie, like Lord of the Rings or one of these other Rajamouli movies, which are incredibly long. Now, the interval is called the 50 percentile number. The movie aspect from 0 till the interval, and then take the half of that, right? The first half of the interval is called the 25th percentile number, and the half of the second interval is called the 75th percentile number, right? Everybody clear about this? Just say clear, CLR. Excellent. Now, I need to know, because I'm a mathematician and I have to make it complex, I simply do a trick. What is that trick? I have to get a new definition, and this is called this number. This range is called the interquartile range. Okay. So what is the interquartile range? So the range between 25th percentile and the 75th percentile is called interquartile range. Okay. So fancy word is IQR, right? Very, very easy. So here, what is the interquartile range? 2, 2, 3, 3, 5. That's it. That's the IQR. Guys, you clear about IQR? Very, very simple. Or you want me to repeat? Let me actually repeat once. Step 1, find the 25th percentile. Very easy. How do I do that? I take the median, and then the first half, I again take the median, right? Second, step 2, find the 75th percentile. I go to the second half, right? Then I take the median there, right? Now, what is the IQR? The difference between the 75th percentile and the 25th percentile there, right? So mathematically, okay, this is a nice box plot representation of this, right? What is a box plot representation? One second, let me get rid of this drawing. Okay. So this is the IQR. Anywhere from Q1 to Q3 is called the IQR, every number between that. So the median obviously lies between that. The min and the max do not lie in the IQR. They are outside the IQR, right? And the definition of an outlier, right, is very easy. The definition of an outlier is, so yeah, mathematicians have given a formal definition. Any data point that lies beyond the okay, very simple definition. Any number or data point that lies beyond max plus 1.5 times IQR, max plus 1.5 times IQR, or min plus, is it min plus or minus? Oh, sorry, min minus. Min minus 1.5 times IQR is the outlier straight away. That's it. So in this case, let's say this was a data set, I made it up. And I'm going to just call this J's data set. J's data set, and today is a Wednesday, so I'm just going to call today J's Wednesday data set, some fun data set, right? So what is the IQR here? So in this case, how much is the IQR, guys? IQR is pi minus 2, 3. Can I say IQR is 3? Right? So outer cutoff is max. So max, sorry. How much was my max here? So I don't have to write that. I think that's just obvious. So let me get rid of that. So it's max plus, so that's 9 plus 1.5 times IQR. How much is this, guys? Can anybody tell me what is the number? Quickly. Good, Vamsi. So yeah, 13.5. So any number that comes beyond 13.5 strictly is a outlier. So in J's Wednesday data set, if suppose somebody comes in, let's just say Captain America comes in and he says, hey, you know what, add me, I am at 14. Is a Captain America data an outlier? And this outer cutoff, inner cutoff, I've just made it up. You just don't have to remember that. Any numbers beyond this is. So what is the inner cutoff? Guys, what is the inner cutoff here? Yeah, minus 3.5. Very good. So that is the danger zone. Okay. So numbers, so minus infinity, all those numbers until minus 3.5 are all going to be given a red symbol by me. So any numbers from there to minus 3.5, minus 3.4, all that's fine. Until 1, they're all fine. Right? Same thing here. Any numbers from 9 to 13.5 is fine. It's not going to change this data set, the original J's data set, right? But my outer cutoff, anything after 13.5 till infinity is all dangerous. Oh, damn. Guys, you clear about these two? If you're clear about these two, just type CLR. You've pretty much understood most of data science. The outlier is the most trickiest thing. That's it. If you're clear about how I got these numbers, very easy. So now I think very easily you can go back to that Bill Gates, that salary, right? The original data set was 40K, 80K, and 100K. So you definitely knew, see, you automatically knew it. See how intuitive you guys were that you figured out the $1 billion was an outlier. $1 billion is way, way, way far away from 1.5 times even the max, right? Let's say the IQR here is 60K, 1.5 times 60K is 100K, 1.5, 60 is 90K. So 90K is very, very different from 1 billion, right? Same thing about weather data. So weather data will have some data points. Now, if you're very, very far away from the IQR, you're pretty much gone, right? So that's how people understand what is outlier. There are many other ways to detect outliers and all that. We are not going to worry about that. But this is a plot. So these numbers, remember here I put these numbers. So for fun, because I'm a mathematician and I have to, again, make easy things look complex, I will transpose these numbers. Voila. So I have these numbers, right? Minus infinity, 3.5, 3.5, 1, 2, 3, 3. So this can be represented very elegantly, this horizontal set of numbers, by a plot called box whisker plot. Can you see this plot now? And of course, the color is different. The numbers between Q1 and Q3 are called the interquartile range. We need those. Numbers beyond that are called outliers. I think now you understood it. All of you should be able to do it on Excel sheet, guys. Guys, you clear about this? Okay, good. So what I'm going to do now is I'm going to plot the same box plot for temperature, right? And instead of making it vertical, I'll make it horizontal, because we've just looked at a horizontal example. So my body temperature, and I just plot the body temperature of all those mammals. So seems like there are some mammals that are more than 99.5 clearly outliers within that data set, right? And there are some animals within 97.0 as well. So maybe they're cold-blooded animals, right? Maybe it should be a reptile, or I don't know what, lizard or something like that. Let's look at the Titanic age. Very interesting distribution. There are some people on Titanic who are like 65 plus. Some people are 80 plus. All of them are outliers on this data set, right? Let's look at a few more on the total sleep. Okay, for some reason this didn't print out the total sleep, but anyways, you'll get maybe there is no outlier. That's weird, but sometimes it happens. There need not be outliers as well. Okay, so let's try to look at distributions of histograms and box plots as well. So I'm going to look at the distribution of men and women in the same plot encoded nicely. Encoded means color coded, etc. So I'm going to say the same. I'm going to provide subplots. Then I'm going to say ax dot histogram, Titanic male age, label male, color blue, and for female I'm going to say age female red. Right. Let's look at how nicely this diagram comes. Wow. Right. Obviously, men are more than women. We've seen that, and this is the plot. Both of which are right skewed. Men and women are right skewed. Let's look at the box plot of men and women. So I'm going to do the same. Dot box plot, Titanic age, Titanic female, labels men and women, right? Voila. Seems like women had no outliers. Very, very interesting. So this is actually a very unique insight. Can you actually see how remarkable it is? We figured out that all the women were actually, very neatly distributed. No skew, no, not skew. There was a right skew, but no outliers. Men were right skewed and had outliers. Okay. Next, look at same box plot for age and sex. And perfect. Yeah. So what do you do with these kind of insights? Well, first off, if you're doing a consulting project, you tell the client straight away, right? Many clients don't even know how to do a simple Excel sheet and actually see many of these things, right? So for instance, let's look at the Covin Indian dashboard. You'll be surprised to know the kind of hideous graphs these guys have. Maybe we should actually do it as an assignment. These graphs are okay, but state-wise vaccination, etc. You can actually see if they had given granular data, you can actually see how many of, let's say, 47-year-olds got vaccinated, how many 80-year-olds got vaccinated, etc. Or actually, there's some distribution here. And they give APIs, so you can get the raw data, I guess, right? And see some interesting trends. You can actually plot all the states, see their number of vaccination doses they got. You can see how many states have got are outliers or not. Like, have some states been discriminated heavily? Again, we don't want to get into politics, but for some reason, maybe those states got discriminated because of, I don't know, they had low cases, and that's why they felt maybe they should get less dosages, so on and so forth. So box plots are a great way to figure out all of these. Let's look at some normal distributions again. Yeah, okay. The hallmark of data science is one of the hallmarks is in understanding normal distributions really well. You have seen this time and again in your I'm sure 10th grade, 12th grade, so on and so forth, all your exams. We really need to know, because a normal distribution has this beautiful symmetrical property where the mean, mode, and median are the same. Almost never does it happen in real life. But to know what is the idealistic is important, right? So for instance, just making it up, like, the best idealistic cricketer, I'm just making it up, is Virat Kohli, or the best baseball player, or the best basketball player is Michael Jordan, or something like that. When you know the idealistic, you can start knowing what is a deviant, what are data points that are away from it, so on and so forth, right? So even though we don't see this very often, we have to know what it is, right? So yeah, so normal distribution, we know that has mean, mode, median equals 0. Sorry, is the same. In a standard normal distribution, all of them are equal to 0. And one beautiful property, which we'll see again as well, is within the first standard deviation. And I've just brushed upon this topic of standard deviation. We'll look at that again, but it's good to introduce and see these concepts again and again and again and again. Within the first standard deviation, you have 68% of the elements, right? Within 2 standard deviations, you have 95% of the elements. And within 3 standard deviations, you pretty much have 99.7% of the elements that are captured. It's also known as the empirical rule, a very nice standard rule. So let's look at what is the definition of a standard deviation. So a deviation is the measure of how far each data point is from the mean, right? So you want to know, let's say, how far from the mean is one data point. You use the standard deviation. So let's go back to our workbook. So we had these nice data points. So let's look at this guy. So this is my Jay's Wednesday data set, right? So I want to see how far is 3 from my mean. So first off, I'm going to check the mean. So equals average of all these numbers. I don't think it's 3. My average is actually 3.6, right? So I want to check how far from 3.6 is each one of my numbers. So I'm going to do this formula. So what is that formula? The number okay, we'll introduce the number. So the standard deviation in this case is the number, okay, wait, 1 minus the mean. Guys, you guys figured out how I got the 2.6 minus 2.6. So 1, the first data point, is around 2.6, of course, to the left of it. So same way I can get the deviations of each of the number. So 2 is, sorry, just toggle my formula. Yeah, now it should be right. Yeah, and the number 2 is 1.6 away from the standard deviation. Yep. Number 2 again is 1.6. Number 3 is minus 0.6. Number 3 is minus 0.6. Number 5 is 1.4. 9 is 5.4. How did I get each of these numbers? I just subtracted them from each other. Nothing extraordinary is happening. These are the deviations. That's the standard deviation from the mean. Okay. Now, can I compare standard deviations of different means? Well, straight from this example, you can't. So this is J's data set, some arbitrary data set. These were salaries. So the salaries themselves are in different orders, right? They're in 40K, 80K, so on and so forth. So you definitely cannot compare the deviations. However, you can do something little nice, that we'll see that a little later. What we can do is when you divide it by n, the total number of observations, you get it to nice smaller numbers, right? So let's look at that. So here's the mean for the body temperature. 98.165 is the mean. These are the deviations. I think we've gone through the deviations. Let me calculate the standard deviation for the entire data set. The standard deviation for the entire data set is it's 0.527, right? So how do I get the upper and the lower end of the three standard deviations? The way I do that is, I've just told you here, right? The lower end is mean body temperature minus 3 times the standard into body temperature. The upper end is, let's say, 3 times mean plus 3 times standard of the body temperature. If you want to do 2 times, you can do 2 times. If you want to do once, you can do once, so on and so forth. So remember, what is the empirical rule? 99.7% of our observations fall within the 3 standard deviations. So everything, most of the numbers fall between 96.6 degrees and 99.75. So most of the animal body temperatures from that fall in this, nothing else, right? So I just plotted the same thing again. Indeed, it seems like 99% of the numbers are falling in this area, right? Can you see this here? All this 99%. Only few animals are there below this and below this. Maybe they were the outliers. Should you take this for granted? Don't take this for granted. It seems very, very intuitive, but it is not. It's actually a very, very, very beautiful case of the normal distribution. So that just concludes the introduction of explanatory visualizations, etc. Now you're able to draw histograms, draw bar plots, draw pie charts. You can see from your own workbook. I also wanted to bring to your notice the importance of misleading statistics, right? So let's look at some misleading statistics. It's very, very important. See, many people, journalists, I mean, they don't do it on purpose, but they just do it. You get misleading statistics, okay? So 2 y-axis, right? When you have 2 y-axis, it's very difficult to actually comprehend the units. So on the left side here, it's weight, versus on the right side, it's running number of kilometers. Actually, doesn't make sense at all. So, but time and again, people do this, okay? Same thing here. Online hotel revenue is on the left, number of travel agents on the right. Completely bizarre, right? One order is different, the other order is different. People make lots and lots of mistakes. There are tons of these examples. I've just given them here in this workbook. Feel free to look at that. So with that, we come to okay, one really good example is when you cut the base, like if your x and y axis should always start with 0. Remember that. So because it doesn't start with 0, look at this these politically motivated examples. So this guy is saying, if George Bush were supposed to cut tax rates, this is at 35% and this is at 39.4. But here the order doesn't start at 0. It starts at 34. But if you look at the proper graph, right, it's only very, very less. So it's fine. So I think the governments were doing an okay job at the time, right? So very, very common ways to mislead people, even statisticians and data scientists such as yourself, right? Okay, perfect. So with that, we'll conclude today's session. We have the assignment, etc., for this coming up as well. And any other questions? I will stop my recording right now.